Okay, in this review video we are going to go over the graphs of these basic algebra functions and cover domain and range. So these 8 functions that are listed on this slide are what I'm considering basic algebra functions. So hopefully you have an idea of what their graphs look like almost automatically when you see them come up in problems. As we're looking at these different functions, we're also going to talk about their domain and range. So the domain is the set of all of the inputs. So these are going to be the set of all x values for which your function is defined. If you can identify what type of function you're dealing with, usually that makes it pretty easy to find the domain, because as we can kind of see on this slide, if I'm dealing with a polynomial, I know automatically my domain is going to be all real numbers. So we can write that with the r with the extra line through it, or in interval notation as negative infinity to positive infinity. If we're instead dealing with a rational function, the thing that we have to remember there is that we can't divide by 0. So remember, rationals are really just a fraction of 2 polynomials. So to find the domain, what we're going to do is set our denominator equal to 0 and then exclude those values that would make my denominator equal to 0. Radicals are problems that have a square root or cube root in them. As we're finding the domain for those types of problems, what we need to remember is that we can't take the square root of a negative number. So whatever we have underneath our square root symbol, we have to set that greater than or equal to 0 and then solve that inequality to find our domain. Logarithms, that's kind of the next type of function we're looking at here as far as the domain goes. What we have to remember when we're finding the domain is that we can't take the log of anything that's less than or equal to 0. So what we want to do is set the quantity inside our log greater than 0 and then solve that equation. As we're finding our range, those are the outputs, so the y values. So if you kind of think about the difference between your domain and your range, the domain's going to be what's going on horizontally on your graph. The range is going to be what's going on vertically in your graph. Alright, so if we look at our first function here, we're looking at a constant function. So f of x is equal to c. So c is just a constant. If we graph this, what we're going to end up with is a horizontal line. So as I'm looking at this, I can put any value of x that I want to into this function. So I know my domain would be the set of all real numbers, or in interval notation again, negative infinity to positive infinity. The range again is a set of all y values that are going to come into play on our graph. So as we're looking at this, there's really only one y value, right? So we're just looking at the set of all c, because that's the only y value that we're going to get out for our constant function. Our identity function here is the equation f of x is equal to x. So remember, f of x is just the same thing as y. So you can also think of this, if you want to, as the equation y is equal to x. So this would just be a straight line. Your intercept through the y-axis would be 0, and your slope is 1. So as we're looking at this graph horizontally, we can see my domain again would be all real numbers, as well as my range. As I'm looking vertically, we can see that we would get out all values increasing and decreasing to the right and to the left. Alright, so the third function that we're looking at here then is our square function. So this is f of x is equal to x squared. You might recognize this as a quadratic and the graph as a parabola. So if we look at our domain here, we can see that the domain, as I'm looking horizontally from left to right, would again be all real numbers, so from negative infinity to positive infinity. But my range, as I'm looking vertically, we can see that nothing happens below a y value of 0. So as I'm writing my range, I know all of my y values would be greater than or equal to 0. So in interval notation, we have a closed bracket or a square bracket at 0, and then we are continuing up forever, so we go out towards positive infinity. Our fourth function then is the cube function. F of x is equal to x cubed. So as we're looking at both the domain and range in this function, we can see that they would both be all real numbers. So it's going to continue to the left and right forever, and also continue down and up forever as we continue those arrows. Alright, so then the fifth function is our square root function. F of x is equal to the square root of x. As we're looking at this, remember we said for the domain, whatever is underneath our square root, or a radical, has to be greater than or equal to 0. So in this case, what's underneath the radical is an x. So we need x to be greater than or equal to 0. And we can see that from our graph as well, right? There's nothing to the left of 0 as far as my graph goes. So if we write that in interval notation, again, a square bracket, a closed bracket at 0, comma, infinity. If we look at our range, now we're looking at our graph and what's going on vertically, we can see that would be the same thing. My range would also be from 0 to infinity. I'm not going to have any negative y values back out from this function. Alright, so then the sixth function here is the cube root function. So we can see the graph here, and again, that's an easy way to come up with a domain and range. So the domain would be from negative infinity to positive infinity. The range would be the same thing as I'm looking at this graph. Alright, so then the seventh function here is the absolute value graph. So f of x is equal to the absolute value of x. You can see the graph kind of looks like a V shape here. As I'm looking at my domain, I can see that it's going to continue to the left and to the right forever. So my domain would be from negative infinity to positive infinity. My range, now as I'm looking vertically, we can see that there's nothing happening in terms of negative values of x, right? Remember, the absolute value forces it to be positive. So the smallest y value I ever get out is 0. So we're looking at a range from 0, again, a closed bracket on 0, to comma infinity. Alright, so then the last function we have here is the reciprocal function. This is f of x is equal to 1 over x. So this is an example of a rational function. Remember when we said we were dealing with rationals, we need to make sure the denominator does not equal 0. So in this case, my denominator is just x. So if I set that equal to 0, I see that happens when x is equal to 0. So that's the one value that I want to exclude from my domain. So for my domain, I want the set of all x such that x does not equal 0. So that's writing that in set builder notation, listing what property has to be true in order for x to be in that set, which in this case is that x cannot be equal to 0. We could also write this in interval notation if we wanted to, breaking that into two intervals, because I know I'm not including 0. So we're including everything to the left of 0, negative infinity to 0, and then everything to the right of 0, or from 0 to infinity. For the range, we can see from the graph that the range would be the same thing. We're not going to get y value of 0 back out, so I know for my range, this would be the set of all y such that y does not equal 0. Or again, I could also write this in interval notation, not including 0, so breaking that up into two intervals, open brackets on 0, indicating that we would not include 0 for either interval there.